So I've just got just your basic water,
Yeah,
nothing
drink
but
it.
leaf presto, and
Please do
why is
yourself.
my pH probe reading way, 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 way too high?
Bert, can I have some of that PI water?
Do you think that's like better tasting water?
I don't know.
I feel like Alan had some.
You
probably
I was making a joke.
But he's
No, it tastes better. No, it tastes better.
No,
It tastes better.
And then
It
Trust
is
me,
basic water.
it
It's
tastes
like
better.
9.7.
I was being funny.
What do you think this tastes like?
Oil.
Oh,
Nick,
come
I
on.
could taste
I'm worse
pretty
than
good.
Alan Hire.
Why does it look like that?
Yes.
You talking about?
This
This is what all.
Okay, this might be a little bit sketchy because this pH should obviously be
so
closer
sticky,
to
bro.
7 and it's like at 9.3, but hopefully it still works. So here's what I'm going to do. I'm going to add ammonium nitrate. So let's start with this. What's the formula for, not ammonia, but ammonium nitrate?
NH4 plus.
Ammonium is NH4, 1 plus.
NO3.
Nitrate is,
NO3 minus.
NO3 is the charge of,
Minus.
so we just get NH4, NO3, right? So I'm going to add this to water. Is this going to be soluble?
Yes.
Yes.
Absolutely, for 2 reasons.
Nitrate.
All nitrates are soluble,
And ammonia.
and ammoniums are soluble. You could not get this thing to make it precipitate if you tried, okay? So I'm going to dissolve this in water, which means I'm going to have some ammonium ions floating around, and I'm going to have some nitrate ions floating around. Do you think the nitrates are going to do anything with the water?
No.
No, why not?
They're nice and strong. They don't care.
Beautiful. It's conjugate base off of strong acid. Nitrate is there, doesn't matter. Okay, nitrate goes, hey, you guys do you, I'm good. Okay? So, the ammonium, NH4 plus, is going to react with water. What could happen? There's 2 things that I could get from the reaction of ammonium and water. What's one of them?
Hydronium.
I could get H3O plus and
Ammonia.
NH3. Okay? Now, if this happens, what should happen to the pH? It should go down. Why? I'm generating hydronium ions. That's an option. What's your other option? So this could take another hydrogen from the water, and if that case, you would make what? NH5 plus 2 and hydroxide. If this happened, what should happen to the pH?
Go up.
Go up. So this is an easy way to see what's going to happen. Either the pH goes down, pH goes up. Now, but this is pH is so far off what it should be to begin with. This is what should happen. Okay, so the pH should, in theory. Oh, we got down to 8.46. Cool. Okay, so I'm going to take some ammonium nitrate and give that. Oh, that was a lot. Okay. So stir this up, and it immediately starts to drop. So we were at like 8.5, and now we're down to like 6.7. So it dropped. So that pH dropped like a rock. So what does that tell you?
There's hydronium.
So the ammonium acted as what? An acid or a base?
Acid.
Acted as an acid. But is it an Arrhenius acid or Brownstead-Lowry?
Brownstead-Lowry.
Brownstead-Lowry. Brolo. Why?
It donated a proton.
Yeah, because number one, this doesn't in any way, shape, or form look like an acid. It's like HCl, H2SO4, something like that, right? Look at this, oh, that's an acid. No, it doesn't. Hydrochloric acid should be something like that. But by the Bronsted-Lowry definition, it is an acid. So in this situation, what's the water acting as? Base. The base. So H3O, conjugate acid, conjugate base.
Conjugate acid. Conjugate
What's this going to
acid.
be? Conjugate acid. This is going to be your conjugate base. Thank you very much. Wow. Okay. So now, in contrast to that, so take some more water. This probe. Okay. Now, in contrast to that, now I'm going to add some sodium carbonate. Okay? So, come on, work with me here. So the pH is 7.72. I'm going to add sodium carbonate to it. Like that. That's such a non-precise measurement. But the pH was 7.72. I give this a stir, and the pH shoots all the way up to like 11.3. So, why did adding sodium carbonate make the pH shoot up so high?
Because the carbonate is a conjugate base of a weak
So you got
acid.
sodium carbonate, right? Soluble or insoluble?
Soluble.
How do you know it's soluble?
Sodium.
Sodium, group 1, right? So this is just going to act as CO3 2 minus. It's going to react with water. True?
True.
Why?
Because it wants
It
that
wants to
H
get,
back to base. Like,
it wants to get clumpy.
clumpy.
Okay? Why does this want to get clumpy?
Conjugate base of a weak
Conjugate base
acid.
off of a
Weak acid.
weak acid. So you're going to reform the carbonic acid, and what's going to be left over? Hydroxide. You're going to generate hydroxides. Miracle of miracles, you're going to generate hydroxides. The pH is going to go up. Cool. Now, if I put sodium chloride in water, what's going to happen to the pH?
Absolutely nothing.
Absolutely nothing. Why?
Because it's not clumpy.
Yeah, okay, the sodium is going to act as Na+. Does it have a spare proton to give like the NH4 does? No, okay? It doesn't. It has no protons to give up. What about the Cl1 minus? Is that going to react with water to do this? Is it going to make HCl and hydroxide? No. Absolutely not. Why? It has no desire to get clumpy. Carbonate wants to get clumpy. Wants to get its clump on. This doesn't. Okay? What's he going?
I didn't like
Stop.
This is
Okay.
the greatest thing.
Got the idea? Back you go.